In this video, we're going to take a look at exam revision for factors, multiples, and primes. So all we're going to do here is run through some exam style questions for this as the topic, so let's just jump into the first question here. So for the first one, we have to write down a multiple of 8 that is between 20 and 35. So for a multiple here, if you struggle to remember the definition of a multiple, then the easy way to remember this is to think about the times table of that number. So if we're looking for a multiple of 8, then that's the 8 times table. If we just jot that down over here, I've got 8, 16, 24, 32, and so on. So we just go up to 40, 32, and 40 there. And that would obviously keep going on. Now we're looking for a multiple of 8 between 20 and 35. So if we look back at our 8 times table here, what numbers do we have between 20 and 35? Well, 8, 16, and 24, 8 and 16 are below 20, so we won't include those. But 24 is between 20 and 35, so we can have that. 32 here is between 20 and 35, so we can have that. But we can't have 40. That's greater than 35, and then clearly anything else will also be greater than 35. So in that case, we've got two possible options here for a multiple of 8 between 20 and 35, and we can say either 24 or 32. So let's just say 24 here is a multiple of 8 between 20 and 35. And that gives us the solution to the very first question. The next one here, pretty similar. Write down a multiple of 7 that's between 30 and 50. So in this case, because we're talking of the multiple of 7 here, and we just think about the 7 times table. So we've got 7, 14, 21, 28, 35, 42, 49, and so on. Okay, that would obviously keep going on. So now let's just check which numbers here are between 30 and 50 in our 7 times table. So 7, 14, 21, and 28. We won't include those because they're all below 30, so we don't include those. Now we've got 35, well that's between 30 and 50, so we can include that. We've got 42 here, again that's between 30 and 50, so we'll include that. And same again here for 49, that's between 30 and 50, so we'll include that. But any number passes now in the 7 times table here, so the next one would be 56. That's above 50, it's greater than 50, so we can't include that. So we've got three options here, 35, 42, and 49. So any of those three would get you your mark here. So if I just pick 49, that would be absolutely fine. That would get us our mark there to the second question. Moving on to the next one here now where we're talking about factors. So factors, again, if you struggle to remember the definition, what I like to think about here is just a very basic example. So factors are numbers that we can multiply together to get another whole number. So if I do 5 times 3, and that gives me 15, then what we're saying here is 5 and 3 are factors of 15. So they're numbers that go into another number. So in this case, because we're looking for two factors of 15, we've already technically done that here. 5 and 3 are two factors of 15. So 5 and 3, that would be two factors of 15. But I can also pick something else here. I could pick 15 and 1, because if I do 15 times 1, we get 15 there. Okay, so I can also pick 15 and 1 there. Okay, so either of those would get us our mark for that one there. And then same again here where we're asked to now write down two factors of 12. So again, just pick two numbers here that when you multiply them together would give us 12. So a couple of different choices here. Straight away I could pick 6 times 2. So I do 6 times 2, that gives me 12. Okay, so in that case we could say 6 and 2 are two factors of 12. Okay, so have a think now, can you think of any other two factors here of 12? And hopefully you might spot another couple of examples here. I could do 3 and 4. So 3 times 4 gives me 12 there. And I can also do 12 times 1. So 12 times 1 would give me 12. So we can say here 3 and 4 are also factors of 12. And 12 and 1 there. Okay. And there we have it. So any of those there would give us any two factors of 12. And that's our solution to that question there. Moving on to this question here now, where we're taking a look at prime numbers. So for the first question here, we're asked to write down a prime number between 20 and 30. So we need to understand what a prime number here is. So what's a prime number? Well, a prime number is only divisible by 1 and itself. So for example here, 6 is not a prime number. So 6 is not a prime number. And the reason for that is because I can divide it by, say, a number other than 1 and itself. So I could divide 6 by 3. So I do 6 divided by 3 here. Then we get 2. Okay, so 6 in that case is not a prime number. However, 5 would be a prime number. So 5 is a prime number. And the reason for that is because I can only divide 5 by 1 in itself. I can't divide 5 by 2, I can't divide 5 by 3, and I can't divide 5 by 4. So I can only divide it by 1 and 5, and hence 5 would be a prime number. So if we're looking for a prime number between 20 and 30, what we need to do now is just test those numbers between 20 and 30. So 20 won't be prime because I can divide that by 2, I could divide it by 10. So 20 is definitely not prime. So what we'll do is we'll write down all the numbers. So I've got 20, 21, 22, 23, 24, 25, 26, we're going to room a little bit here, 27, carrying on underneath, 28, 29, and 30. Well, 20 is definitely not prime. Okay, that's an even number. We can divide it by 2. 21 here, well, I can do 7 times 3. I can divide 21 by 7. So I can divide that by 7, so that won't be prime. 22 here, again, it's even. I can divide it by 2, so we won't include that. 23 here, so can I think of any number that I can divide 23 by? That would give me then a whole number. Well, in this case, I can't. I can't divide it by 2, I can't divide it by 3, can't divide it by 4, and so on. So for that reason, I can only divide 23 by 1 and 23, and for that reason, that makes 23 a prime number. So 23 is prime. 24 here, again, this is even, so we won't include that. 25 here, we can divide that by 5. 5 times 5 would give me 25, so that's not prime. 26 here, that's even, so we can't have 26. 27, can I think of any number that I can divide 27 by? Well, I can't divide it by 2, but I can divide it by 3. 27 divided by 3 would give me 9, so 27 is not prime. 28 here is even, so we can't include that. 29, well, if I think about it, can I divide it by 2? I can't. Can I divide it by 3? I can't. Can I divide it by 4? And so on. And what you'll find is we can't divide 29 by any whole number there. So for that reason, it's only divisible by 1 and itself, 29. So for that reason, 29 is a prime number. And then finally 30 here, again, that's an even number, so it's divisible by 2. So that leaves me with 2 options here for a prime number between 20 and 30. So I can either pick 23, so 23 or 29 there. Okay, and there we have it. So that's our solution to that question there. And for the last one on this page, then we have to write in the only even prime number. So there is actually only one even prime number, and that even prime number is the number 2 there. Okay, that's the only even prime number, and that's why we can instantly rule out any even number here in this list, because there's only one even prime number, and that's 2. So obviously 20, 22, 24, 26, 28, and 30. We know instantly that they can't be prime because they're always divisible by 2. In that case, the only even prime number is 2, and that gives us the solution to that question. Moving on to this question here now, what we've been given is a list of numbers, and from this list we need to identify all multiples of 3. So because we're talking about multiples of 3 here, so multiples of 3, that means we need our 3 times table. So we've got 3, 6, 9, 12. And what I'll do here is I'll go up to 30, so I've got 15, 18, and like I said, I know this is quite a basic way to think about it, but I do think it helps if you struggle to remember the definition of a multiple. 27, and then finally 30 here underneath. So that gives us our 3 times table there, and what I need to do now is just use this list here and cross-reference that with our 3 times table here. Okay, any number that's in both lists means that it's a multiple of 3. If I've got a 3 here, and I've got a 3 here in our 3 times table, that means 3 is a multiple of 3, so we include that. I've got 8 here, there's no 8 in my 3 times table, so we don't include that. I've got 12 here, and again I can spot that here in my 3 times table, so we include 12. 15, well we've got 15 as well, so we include that. I've got 19 here, we have no 19, so we don't include that. And then finally we've got 30 here, and we've got a 30 there, so we include that. So in that case, we've got 4 options here. Well, we want all the multiples, so we need to jot them all down here. So I've got 3, 12, 15, and 30 then. Okay, so 3, 12, 15, and 30 gives us all the multiples of 3 from that list of numbers there. Okay, and that gives the solution to that question. And moving on to the very last question here, again, all I've been given is a list of numbers, and from this list we need to identify all prime numbers. So remember, a prime number is a number that's only divisible by 1 and itself. So what I need to do then is just go along each number here in the list and check whether it's divisible by 1 and itself. Well, straight away we can cross quite a few of these off. So 1 is not a prime number, so we can cross 1 off. 2 here, well, 2 is an even number, but it's the only even prime number. So we know that one will be a prime number, so we'll include that. 3 here, well, 3 is also a prime number. It's quite a small number, and we know that's prime because it's only divisible by 1 itself. We can't divide 3 by 2. In that case, 3 is a prime number. Have I got any even numbers here? Well, 8 is an even number. We can't have that as a prime number then. There's only 2 that can be an even prime number, and that means we can't have 24 as well. That's also even. And then any number that ends in a 0 or a 5, or the last digit is a 0 and a 5, that can't be prime. So in that case, 15 can't be prime here. So in that case, then we only need to check a few options here. We need to check 13, 19, and 47. Okay. So can we think of any number that we can divide 13 by other than 1 and 13? Well, we can't divide it by 2, can't divide it by 3, can't divide it by 4, can't divide it by 5, can't divide it by 6, and obviously we can't divide it then by 7. So in that case, 13 would be a prime number. 19 here is 19 a prime number. Well, I've just got to think, can I divide 19 by any number other than 1 and 19? So you just go through the numbers here. I can't divide it by 2, I can't divide it by 3, can't divide it by 4, can't divide it by 5, and so on. And what you'll discover here is 19 is a prime number. And then finally we arrive at the very last number here, 47. So is 47 a prime number? Well, I can't divide it by 2, can't divide it by 3, can't divide it by 4, and so on. And again, just check all those numbers, and what you'll find is 47 is a prime number. Okay, we'll give that a tick. So because we want to identify all the prime numbers, what we'll do is we'll just write them down here. So we've got 2, 3, 13, 19, and 47. That gives us all the prime numbers there from that list, and that gives the solution to that question. Okay, so let's just double check. 2, 3, 13, 19, and 47. Perfect. Okay, and that's our solution to that question. And that brings us to the end of this video on factors, multiples, and primes. In the next video, we're going to take a look at exam revision for coordinates.